In recent years, we've witnessed the remarkable emergence of artificial intelligence that can converse, write, and even create with astonishing fluency. These systems, often perceived as almost magical, are powered by something called large language models, or LLMs. Imagine interacting with a computer that can not only understand your questions but also generate thoughtful, coherent, and contextually relevant answers, almost as if another person is on the other side. This isn't science fiction anymore, it's our present. But how do these incredible digital entities actually work? What lies beneath their seemingly intelligent surface? At their core, large language models are sophisticated computer programs designed to process and generate human language. Think of them as incredibly vast and complex digital libraries, not of books, but of language patterns. They don't think or understand in the human sense. Instead, they are trained on immense amounts of text data from the internet, books, articles, websites, conversations, learning statistical relationships between words and phrases. Their primary function is to predict the next most probable word in a sequence, creating sentences that sound natural and relevant. The large language models isn't just a catchy name, it refers to the colossal amount of data they are trained on, and the sheer number of parameters they possess. To give you an idea, these models might ingest trillions of words from virtually every corner of the internet. This includes everything from classic literature to modern web pages, scientific papers to casual social media posts. The diversity and volume of this training data are crucial, as it allows the model to encounter an almost infinite variety of language uses, contexts, and styles. The architecture underpinning LLMs is a type of artificial intelligence called a neural network. Inspired by the human brain's structure, neural networks consist of interconnected nodes or neurons organized in layers. Each connection has a weight which determines the strength of the signal passing through it. During training, the model adjusts these weights based on vast examples of text, gradually improving its ability to recognize patterns and make accurate predictions. It's a complex dance of mathematics and data, refining its internal map of language with every new piece of information. While neural networks are the foundation, a specific innovation called the transformer architecture is what truly unlocked the potential of modern LLMs. Introduced in 2017, transformers excel at understanding context over long sequences of words. Before transformers, models struggled to remember the beginning of a long sentence by the time they reached the end. Transformers use something called attention mechanisms, allowing them to weigh the importance of different words in a sentence relative to each other, no matter how far apart they are. This breakthrough vastly improved their coherence and contextual understanding. So, how do LLMs generate responses? It all boils down to predicting the next word. When you type a prompt, the LLM processes it and then, based on the statistical patterns it learned during training, calculates the most probable word to come next. It does this word by word, or more accurately, token by token. Each prediction influences the next, creating a coherent flow of text. It's like an incredibly sophisticated autocomplete function, but one that can generate entire essays, stories, or complex answers, maintaining context and style throughout the process. To manage and process vast amounts of text efficiently, LLMs don't typically work with individual letters or even whole words directly. Instead, they break down text into smaller units called tokens. A token can be a whole word, part of a word, or even punctuation. For example, the word unbelievable might be broken into undash, believe, and able. This approach allows the model to handle a wider vocabulary and more complex language structures, as it can combine these fundamental units in endless ways to form new words and meanings, optimizing its understanding and generation capabilities. It's vital to reiterate that LLMs operate based on patterns and statistical likelihoods, not genuine understanding or consciousness. They don't know what a cat is or feel joy. When an LLM generates text about a cat, it's because it has seen billions of examples of the word cat used in various contexts, alongside images, descriptions, and related concepts in its training data. It has learned the statistical probability of certain words appearing near cat or in sentences related to cat. This distinction is crucial to avoid anthropomorphizing these powerful tools. Due to their extensive training and sophisticated architecture, LLMs are incredibly versatile. They can perform a wide array of language-related tasks. Beyond simply answering questions, they can summarize lengthy documents, translate languages, write creative content like poems or stories, generate different kinds of creative text formats, and even assist with coding. Their ability to adapt to various linguistic challenges makes them powerful tools across many industries and personal uses. It's a testament to how far statistical modeling of language has come. One of the most surprising capabilities of LLMs is their apparent creativity. They can generate original stories, poems, scripts, musical pieces, email, letters, etc., based on a given prompt. This isn't true creativity in the human sense, but rather an advanced form of pattern matching and recombination. By learning the structure, style, and vocabulary of countless creative works during training, they can produce new combinations that often feel innovative and imaginative. This makes them invaluable tools for content creators, marketers, and anyone needing a fresh perspective or a creative spark. LLMs excel at condensing information. Give them a lengthy article or a complex report, and they can extract the key points, providing a concise summary. This capability is incredibly useful for processing vast amounts of information quickly. Similarly, their extensive exposure to multiple languages during training allows them to perform impressive language translation. While not always perfect, especially with nuanced cultural contexts, they can bridge communication gaps across different linguistic backgrounds, making information more accessible globally. These functions highlight their utility in everyday tasks. Despite their incredible abilities, LLMs are not without their flaws. One significant challenge is hallucinations. This refers to instances where the model generates confident but entirely false or nonsensical information. Because LLMs are designed to predict the most probable next word, they sometimes prioritize fluency and coherence over factual accuracy. If they haven't encountered enough reliable data on a specific topic, or if there's ambiguity, they might invent plausible-sounding but incorrect details. It's a reminder that their output always needs human verification. Another critical limitation arises from the training data itself. If the vast datasets LLMs learn from contain biases, reflecting societal prejudices, stereotypes, or underrepresentation of certain groups, the LLM can inadvertently learn and perpetuate those biases. For example, if historical text data disproportionately associates certain professions with one gender, the LLM might exhibit that bias in its generated text. Addressing this requires careful curation of training data and ongoing efforts to fine-tune models to promote fairness and inclusivity. The power of LLMs brings with it significant ethical considerations. Beyond bias and hallucinations, there are concerns about job displacement, the spread of misinformation, plagiarism, and the potential for malicious use, such as generating propaganda or phishing attempts. Developers, policymakers, and users all have a role to play in navigating these complex issues responsibly. Establishing clear guidelines, promoting transparency, and fostering public education are crucial steps toward ensuring these technologies benefit humanity without unintended harm. Despite their limitations, LLMs are already transforming many aspects of our lives. They power the chatbots that assist us with customer service, help us write emails, draft creative content, and even generate code snippets for software developers. Many search engines are beginning to integrate LLM capabilities to provide more direct and comprehensive answers. From improving accessibility for people with disabilities to speeding up research, their practical applications are vast and growing, hinting at a future where AI assistance is commonplace. For professionals and students alike, LLMs are becoming indispensable productivity and research tools. Imagine quickly summarizing long scientific papers, brainstorming ideas for a presentation, or even getting assistance in formulating complex arguments. They can help overcome writer's block, provide diverse perspectives on a topic, or even simplify technical jargon into understandable language. By offloading routine linguistic tasks, LLMs allow humans to focus on higher-level thinking, creativity, and critical decision-making, augmenting our intellectual capabilities. The flexibility of LLMs extends to their customization. While foundational models are trained on general internet data, they can be fine-tuned on more specific datasets. This process adapts the model to particular domains, industries, or even personal styles. For example, a legal firm might fine-tune an LLM on legal documents to make it an expert in legal language and precedents. This customization allows businesses and individuals to tailor these powerful tools to their unique needs, unlocking specialized AI assistance that goes beyond generic capabilities. The field of large language models is evolving at an incredible pace. Researchers are continuously finding ways to make them more efficient, more accurate, and less prone to bias and hallucinations. Future advancements might involve models that can integrate information from multiple modalities, not just text, but also images, audio, and video, leading to even richer and more nuanced interactions. The trajectory suggests an increasingly sophisticated AI landscape, where these models become even more deeply integrated into our digital lives, offering profound benefits and posing new challenges. As LLMs continue to advance, the emphasis on responsible development grows stronger. This means building AI with transparency, accountability, and ethical considerations at the forefront. It involves not only improving the technical aspects, such as reducing bias and improving factual grounding, but also fostering public understanding and engagement. Open discussions about AI's societal impact, potential regulations, and inclusive access are vital to harness its power for good. The journey with LLMs is just beginning, and how we choose to navigate it will define its legacy. Large language models represent a transformative leap in artificial intelligence. They are not sentient beings, but rather incredibly sophisticated statistical engines capable of processing and generating human language in ways that were once confined to science fiction. By understanding their underlying mechanisms, their strengths, and their limitations, we can better appreciate their potential and navigate their challenges. They offer a powerful set of tools that, when used wisely, can augment human creativity, boost productivity, and open new frontiers of knowledge. The conversation about these models is ongoing, and their story is still being written by us all.